Hello. So let me open this and let me open a new. Uh, okay, so we'll draw it here. So what we are trying to do here is, so this is the question. We need to find the Hamilton weight. Hamming weight is nothing but, let's say Hamming weight is nothing. It is something for you in English. Hamming weight is the number of ones or the number of non-zero elements you can find in a number. Okay, another way to this question is how many set digits are there, right? So if I wanted to find out how many set digits are there in a number, I would need to use shifting, bit shift. What we can do is, if let's say the number is uh, 0 1 0 0, something like that. Now we need to check how many Hamming weight or set bits are there. Here three are. We need to write the program to somehow uh, get this output, right? So what we can do is, we can, like, we, I explained it in a different way. Like, we can loop. We can first, if they gave any decimal number, we'll first loop it and convert it into binary number by like n mod less than normal division kind of thing. Then after we get this, we will loop. We will convert this into a string and we will loop each one and we will check if that particular item, not item, that particular string value is equals 1, then we will increment it by 1, the count by 1. So that's the normal method, but that's not the optimal method, that's the brute force method. So now what we are trying to do is, we are trying to do bit manipulation using shift. So what we can do is, let's say, how we can find out if a particular element is element is bit is set or not. We can do, let's say, uh, 0 1 0 1 0, and if you do ampersand 1, what would happen is, so here 0 1 0 1 would be there, and 1 would be written like something like this. I'm not writing all the numbers because it would be tiresome. Say 0 is here. Similarly here, let's say it's something like this. Okay, yeah. So we would, if we do AND operation on these, like here, if we do AND operation, we would get what we would get. We would only compare the last digit, right? So only the last digit would be, if the last digit is, let's say, 1, then we would get it as 1. If it's not, then we would get 0. So this way, no matter how many numbers are there after the after the last digit, we would be able to like guess if this particular thing is equals, sorry, uh, yeah, so this particular thing, so if increase the increase count by 1, if it's not, then you will not increase. Can do is we can loop this number using right shift. So what we would do is, we know what right shift would do. Like if we do right shift one time, what would happen? The rightmost element would be removed and a 0 would be added at the end, right? So this would be the right shift. Now what we are doing is, we will start from the first number, then we would get something, right? We would get, uh, let's say this is there. So we would shift it by 0, which would not shift anything, and we would ampersand 1, right? We would compare all of these with ampersand 1 value which we get. If it is equals 1, then we would count plus plus. If not, we would just move on to the next one, right? Yeah. So let me try to write the code for it. What would be the code for it? Mm, So first, what we need to do, I forgot what I need to do. I'm not good at speaking in code. Yeah, let me check. So I would need to convert this thing. The number, right? Uh, Being equals this, I equals not I and square. What we need to do is being equals n modulus 10, n equals not modulus 10, modulus 2 would be the correct one because we are converting this decimal to binary, right? Uh, So we would use math.float n by 2. We would loop it. At the end of it, we would get bin, right? So what we need to do here is bin not, it's not necessary, but it's better, right? Bin not split, split, convert it into an array first, then we revert array method which is used to like make string, right? Uh, So we got the input in the binary format. Now we need to mm, change it into a check. We need. So how would I check it?